Hey everyone. So we're moving on to section 8.2 using Boyle's law, which is going to be relating the pressure and volume of a system under one condition, then maybe we change something, then we'll figure out the pressure and volume under the conditions of another system. So what I'm doing, hopefully you've printed out or have it open on your computer, the slides for Boyle's law, or maybe the handout that I gave you. So I'm on the Freon problem. So I've listed all our givens and finds, so let me read off the question. We'll go through how I organize all of the data, and then what we'll do is we'll solve it. So it says Freon 12, right? So these are illegal now because they're things that cause the holes in the ozone layer. So it says Freon 12 was used in a refrigeration system. It's asking, what is the new volume of an 8-liter sample of Freon? So that means I started with 8 liters, and I'm going to a new volume. So it's an 8-liter sample of Freon gas, initially at 550 millimeters mercury of pressure, and that pressure is then increased to 2,200 millimeters of mercury. And it's telling me specifically that temperature is constant, and the number of moles of Freon is also constant. And since they're constant, that's why they don't show up in this equation, because they're not changing. We're only looking at things that are changing when we change the conditions. So the way I represented things, it said I had a sample of Freon gas initially. Sorry, I'm off screen. It's just so I can save as much space for work. But the initial volume of the Freon gas was 8 liters. We're asking what happens to the volume when I change the pressure. Well, that 8 liters was originally at a pressure of 550 millimeters of mercury. I changed the pressure to 2,200 millimeters of mercury. What is this new volume of the system? As long as temperature and the number of moles of Freon are constant. So the first thing, how do we recognize it's Boyle's law? Well, T and N are constant, and P and V are the only things changing. That should draw your attention immediately to this equation. So, to help me organize this data, and we haven't done this yet, is the idea of using subscripts even though the symbol for the unit are identical, right? V sub 1 and P sub 1 are describing one system, right? That is a system under this pressure and that volume. P sub 2 is linked to V sub 2 because they're describing the same system. So using the subscripts is going to help us figure out where do they go in the equation. So for us, well, if we look here, and a lot of the times what I like to do is just rewrite the equation where I'm going to do my work. Because I like to start with the variables first, and then I can just dump the numbers in. So P1, I look to my givens and finds. That's 550 millimeters of mercury. That's my P1. My V1 is 8 liters. That's going to be equal, and I'm about to run out of space on the board, so I'm going to adjust the screen just a little bit. Sorry about that. So I have that. I can put in my P2 now, which I have listed in my givens and finds. It's at 2,200 millimeters of mercury. And I'm going to run out of room again. So sorry, it's going to get skewed. This is kind of trying to troubleshoot now that we're moving on to online courses, while still trying to keep a feel for an in-class lecture. And I'm asked to find V2, because I need to have an unknown. If I have an equation, I better have something to solve for, right? So in this case, V2. So what I can do is I can multiply the 550 times 8, right? Let me do that really quick. So if we do 550 times 8, I have 4,400. And that equals 2,200 millimeters mercury times V2. Well, how do I get that V2 by itself? We'll divide both sides by 2,200. So you have 4,400 millimeters of mercury divided by 2,200 millimeters of mercury equals V2. If I do that out, I'll end up with a final volume of 2 liters. So if we visualize what happened, I started with 8 liters. Let me readjust this so we're back looking straight again. So make that about as level as I can. right? So we started with 8 liters at a particular pressure, and what I did was take the 8 liters and I compressed it down to 2. Compressing it is making the volume smaller, the same number of particles in there, but they're smashing the sides faster, right? So the pressure is going to go, the pressure has gone up, right? So they're hitting the walls faster and harder. Not faster, just harder. Nope, that's actually both incorrect. They're just hitting the wall of the container more often, right? If it was changing the temperature, then yeah, they would hit harder and faster. Pressure just means they're hitting it more often because they run into the wall because it's smaller. And it makes sense why we'd have a smaller volume. And so that's Boyle's law.